Question 6a. When magnesium nitrate is heated, it decomposes as shown. I have an equation there showing that happening. A student heats 2.966 grams of magnesium nitrate, which decomposes, as stated in the equation. Calculate the total volume of gas formed in centimetres cubed at room temperature and pressure. So, look very carefully at the equation. It's asking you to calculate the total volume of gas formed. Now, the gas is both the NO2 and the oxygen. Commonly, students miss that fact and only calculate one or the other. Commonly the oxygen, because that's obviously, you know, more familiar with that as a gas. But this equation then, we're dealing with a total gas here of 4 moles of NO2 and 1 mole of oxygen. So for this calculation, I can work out the number of moles of the magnesium nitrate, 2.966 mass over molar mass. The ratio then becomes 2 to 5. There's 5 moles of gas in total on the right hand side. So you could do this in 2 ways. You could do 2 to 5, or you could do 2 to 4 or 1 to 2 for the NO2, and then the 2 to 1 of the oxygen and add them together at the end. But it seems like an unnecessarily long way round when you can just do 2 to 5. That is total volume of gas. It doesn't matter the 2 different gases. That's what the question is asking for. So let's start off with number of moles of the magnesium nitrate, MgNO32, which is the mass over the molar mass, 2.966 over the molar mass of that. Okay, so magnesium 24.3, 2 lots of 14 for nitrogen, 6 lots of 16 for oxygen, gives me 148.3. All right, so the number of moles, therefore, is going to be 0.02, and that will be your first mark for this calculation. Ratio then, 2 to 5. So the way to deal with these odd ratios, it's not as simple as dividing by 2, adding or multiplying by 2, or etc., is you have to make it something to 1 ratio. So you divide by the smallest and then multiply back up again. Okay, so what I would do here is divide 0.02 by 2 to give me the 1 value, and then multiply that value by 5 to give me the final ratio for the total volume of gas. So moles of gas is going to be 0.02 over 2, which is 0.01. Multiply that by 5, therefore 0.05. Okay, well, that makes sense really. 2 to 5 is going to be 0.02 to 0.05, but they're seeing it mathematically and how it's proven. So there's my moles of gas. Therefore, the volume at room temperature and pressure. So therefore, I don't need ideal gas equation. Room temperature and pressure, 1 mole of any gas occupies 24,000 centimeters cubed. I'm looking for a volume in centimeters cubed. So volume is the number of moles of the gas multiplied by 24,000, because I want it in centimeters cubed. So that's going to be 0.05 multiplied by 24,000, which gives me a final answer of 1,200 centimeters cubed.